Good evening, friends. Today, as part of this webinar, we'll be discussing about your exploratory data analysis using R. So, we are going to discuss about your exploratory data analysis, and that is using R. So, are you people aware of what exactly is exploratory data analysis? Yes, friends. Any guesses? Or few of the past participants or who are already undergoing the course, any idea regarding the data exploratory data analysis or data exploration, which is part of your project implementation? Yes. Close to that, analysis on your historical data. What about now? Is the voice clear? Yes, you all are correct. Analysis of the data, visualization of the data, finding interpretation from techniques like box plot, scatter plot, summary, etc. Yes, all absolutely. So we have to put all these things together, and in a step-by-step manner, we have to implement them, and that is called as your exploratory data analysis. And the first thing which is important over here in the project is, first important thing is what is that you need to have. Yes, friends. So, Vinay, are you the only one person who's not able to hear me, or is it a problem from, I mean, from for everyone? So, Charan says he's able to hear me. So, am I audible to everyone? So, maybe there could be some problem from your side because of the network issue. Please try to reconnect. Fine. So, the first most important thing in exploratory data analysis is the domain knowledge. I'm sorry, as part of your project implementation is the domain knowledge. So, in whichever domain you're, yes, we'll come back to, we'll come to that exploratory data analysis. But before that, let me prioritize the things. So, first and the foremost important thing you need to have is your domain knowledge. So, your domain knowledge is nothing but how the process flows. For example, if you are implementing a project in the banking sector, in the banking domain, so you need to know how the process flows, what all things are required as part of your project. You need to have that domain knowledge. So there are two ways to accrue the domain knowledge. One is you would be provided with a subject matter expert by the client, right? So the subject matter expert, he will have the entire domain knowledge which is required to implement the project. Next, if you are unlucky and you do not have the subject matter expert, then what you do is you need to accrue knowledge by research. That is the only thing what you can do. You research over internet or any other means and try to get the information related to the project. What all projects have already been implemented similar to these, and what are the variables talking about. Like in a data set, you'll have a lot of variables, right? In a data set, you need to understand the importance, significance, and what exactly are they used for. So all that knowledge has to be in place. So first, the thing is either get that knowledge from SME or do an online research and get the knowledge by yourself. This is the first most important thing, because unless you understand the domain, you would not be able to implement the project in a proper way. So this is what you have to, this is the first important thing. Then the second important thing is your exploratory data analysis. Once you have understood the domain, then you need to analyze the data. You need to explore the data. So that exploratory data analysis is called as your heart of the project in data analytics. Why is it important? So it is said that 60 to 70 percentage of your project time, yes, has to be spent on EDA.
Hi Saif, this is Hari.
Yes, Hari.
I have one doubt. Yeah, thing is like EDA
Hari.
we need to do once once the variable. Yeah.
Yes, please go ahead.
Are you able to hear me?
Yes, please.
Yeah. EDA will do only once the variables has been finalized, or before we have to do the EDA, or we have to finalize the variables. How it was?
First, you need to finalize the variables. See, first you implement your domain knowledge, right? Based on the domain knowledge, you select the variables. Only after shortlisting of the variables, you start your exploratory data analysis. And Hari, I request you all to please be on mute and post the questions in the chat window. And if you want to ask any questions, please towards the end of the session, we'll discuss.
Oh, okay.
Alright? Yeah.
Because this question is just in between. That's the reason I'm asking.
You can use the chat window and post over there. You can just ping over there.
Okay.
Going through all the messages, and we'll discuss the things towards the end of the session. Fine. So once, as Hari was saying that regarding the variables, first you have, so your domain knowledge is required to select the variables, right? So you'll be selecting the variables and you'll be starting with your exploratory data analysis, and about 60 to 70 percentage of your project time has to be spent on exploratory data analysis. If your EDA is in place, only then your project would be reliable and accurate, and you'll understand more about the variables and the patterns that the data is taking if you spend a lot of time on your EDA rather than rushing up building a model. So that's about your exploratory data analysis and its importance. So let us look at what are the steps involved in exploratory data analysis. So these are the steps. Yes, we'll come to that. So these are the steps which are involved in your exploratory data analysis. Variable identification, right? First is the variable identification. Second one is the analysis of the variables, that is your univariate analysis and bivariate analysis. Understanding the missing values. You need to understand and identify where exactly you have the missing values. You have NA values, it's nothing but your NA values, right? These are the data types. This is analysis of your data types. This is outliers. I believe you people know about the outliers. If at all, if anyone is new and is about to join the course, then this is like an extreme data values, outliers. And then you have to transform the data types and variable creation. So these are the steps which are involved in your exploratory data analysis. Now let us look at these steps one by one. One moment. Yeah. So the first one is the variable identification. So over here, first identify the predictor. Your input variable is also called as your predictor variable, and your output variable is called as your target variable. Next, identify the type and category of the variables. So here's a screenshot of a data type, of a data set, which has got the input, the predictor variables, and target variables. So this is your delivery status is the output variable, and rest of the variables are your input variable. Now this data set is about your shipping company. There's a shipping company or a courier company, you can say. So a reputed courier company data set is for that company, and these were the variables that were shortlisted after putting in the domain knowledge. Now you have got month over here, day of month, day of week, and so on, right? So the first step is to identify the variables, right? So what are you going to do? What do you mean by identifying the variables? What is the data types of month? Yes, friends. What is the integer? But according to the domain knowledge, is it we have something called as numeric category discrete I'm sorry, categorical and continuous quantitative data, right? Categorical and quantitative data. Now your month your month is nothing but a factor variable, right? Because month, day of month, and day of week till here. A factor variable is a variable which can take only limited set of values, right? So a factor variable can take only limited set of variables. Here month can only be starting from 1 to 12, right? Starting from January to December. These are the only values that a month can take. It cannot have any value beyond December. On similar lines, you have day of month which can take starting from 1 till 31 at the max. Those are the maximum number of days that you have in a month. And you have day of week, that is nothing but, again, day of week is nothing but your Sunday to Saturday, right? These are the only days that you have in a week. So these are called as your factor variables. And you have a carrier name over here, carrier name. So this carrier name is also a factor variable because this data set belongs to United States, right, friends? So there would be limited number of carriers. Yes, limited number of carriers will be present in a country, right? They cannot be unlimited. So first of all, it's a character variable, and on top of a character variable, since it is taking only limited set of values, it will be called as your factor variable. Then comes your output variable. Output variable is again your discrete in nature. It can either take 1 or 0. Distance. What is distance? Yes, friends. If the distance is this over here, you have distance in miles. Is it an integer or a numeric? Continuous variable, right? So it's a numeric variable, continuous. And over here, these are nothing but the places. These are nothing but the places starting from source till destination. So there were a lot of places in the data set. It was like names of the cities or the towns. So they were characterized or discretized into different regions. So altogether, I believe there were 9 regions in United States or 7 regions. I don't exactly remember. So all the places were were discretized using these regions. So you have so it can take, again, yes, it is categorical. Is it not a factor variable? You can have, if there are 9 regions, it means that the source and destination can take values only from these 9 regions of United States. Yes, friends, right? And then you have got the shipment delay. This delay is in time. So what is the shipment delay in time? Is it a continuous or a discrete variable? Time, continuous, right? So in that way, you'll have to identify the variables. Again, you have time over here, planned time of travel. This is your continuous variable. So the first and the foremost thing, after you identify the your domain, you put in your domain knowledge and you signify the important variables. You first, what you do is you identify the what are the different data types, right? So this is the first step that you have to perform in your exploratory data analysis. Next, what we do is you perform the univariate analysis, right? you perform your univariate analysis. That is nothing but for each and every individual variable. Over here you can see this is a single variable, this is again a single variable. So you perform analysis on top of each and every individual variable. So if it's a continuous variable, what are you going to do? We have learned from the fundamentals of statistics that these are the measures of central tendency, mean, median, mode, minimum and the maximum values, and you have got measures of dispersion, right? Range, quartile, interquartile range, variance and standard deviation, skewness and kurtosis. Then we have got your histogram and box plot, the visualization methods, right? Which will give you the shape of the distribution and also the outliers. Yes, friends? What about your continuous variables? So on top of which variables can we employ all these techniques? Continuous variable, which all are continuous variables over here? We have got time, right? Shipment delay, planned time of travel, and your destination. Sorry, the distance. So on top of these variables, you can employ these techniques. Next, what if they are categorical? Your factor variables are categorical variables. Just because they take a limited set of values, you employ your proportion table, or you can use a bar chart to look at the proportion of a variable. For example, you have got this particular month over here. So what you do is you plot a bar plot, or using a proportion table, you identify which month is occurring. It's like mode. It's occurring more number of times. That is nothing but the proportion of month in the data set. Proportion of month. Let us say December was the month which was occurring out of 100. It was taking 65% of the proportion. So in that way, you identify the proportion, either using the bar plot or either using the proportion table. So when we implement, we'll implement and look at how the proportion table looks like. It is nothing but you will be getting the output in this fashion: 65%, then maybe 2% for some month, then 3%, 5%, and so on. Right? So this is called as a proportion table. If it is represented in a tabular format, it's called as your proportion table. Next, what you do is you identify the missing values. Right? You have got a lot of NA values in the data set. If you have come across any data sets, you will find NA values. It's for sure that any data set, if you would be lucky and if you do not have any NA values. But which one, Hari, do you want me to repeat?
Yes, I actually earlier you said right percentage 65%.
Okay, all right. So it is nothing but the proportion table. Here, for the categorical, for the continuous variables, you can employ these methods, right? Mean, median, mode, all these first moment business decision till fourth moment business decisions, and then you can also employ your histogram and the box plot, the visualizations, to interpret your shape of the distribution and identify the outliers. Next, for the categorical variables, like for example, here you have the factor variables which were earlier categorical, then we have converted them to factor. So your month, your day of month, carrier name, all those are factor variables. So how do you and what do you do with those categorical variables? You build a bar chart and Also, you can come up with a proportion table. Proportion table is nothing but, for example, it is something like this. Your data set has got this particular variable. First one has got month, right? It will be taking January till December. You'll have June, you have May, you have August, you have again June, you have got December, and so on. So it will identify which month is, what is the proportion of which month, starting from January. So January, if it is occurring 10 times out of 100, so the proportion will be 10 percentage. If February is occurring only one time out of 100, the proportion will be one time. That is called as a proportion. Next is the missing values. Missing values is nothing but your NA values. You have got NA values in your data set. So why exactly the missing value treatment is required? We need to first know what is the reason behind treating the missing values. See, you can see over here there are two data sets. First one has got NA values. Here you have the NA, here you have the NA, right? So it has calculated the probability of, yes, yes, please, what is the question? Friends, as this is a webinar, I request you all to please be on mute, or I may have to mute yourself. So there was a request to go to the univariate analysis slide. Can you please let me know if you have any question related to that? Kalpa? Okay, all right. So the missing value treatment is required. It is because if you identify or if you calculate the probability of playing cricket for male and female. So what is the probability of playing cricket for male and female over here? Before you impute the data, you get to see that here you have male playing yes, yes. Here you have got no. Here you have got no, right? So you have got playing of yes is 1, 2, 3, and 4. So out of 4 you have got 2, and over here playing of female playing is only 1 over here out of 4, right? So your probability of playing cricket for men is 1 over, or rather 2 over 4, and probability of playing cricket for female is 1 divided by 4. Next, what you do is you impute the values, and over here you can see that the probability of, is it 5? Yeah, my bad, 5. Then you have got probability of playing cricket for Y, playing cricket yes for male is over here 2, and 1, 2, 3, 4, and 5. So you have got 2 by 5, and probability of playing cricket for female is 3 by 5, right? So the results were different before imputation. After you have imputed the data, you're getting the different results. So the patterns, the algorithm, how it reads the data will be different. So that is the reason why it will lead to misinterpretation. So that is the reason why your missing values have to be treated. And these are the reasons why your missing values will happen. First one is the data extraction. Say you have got a database using which you are extracting the data to R, or locally using a CSV file. For example, you're extracting the data from this database, some XYZ. So if there is some technical issue or technical glitch, then you may happen to get that you will be finding NA values in your data sets. Random NA values, there is a chance. So that could be one of the reasons for your missing values. Another reason being your data collection, right? Data is it will take a lot of time and money involved in collecting the data. It's not a very easy job. So it requires a lot of time and effort, right, friends? So over here, while the data collection itself, if there are wrong entries made, or there could be n number of reasons while collecting the data why your data is having NA values. So majorly you have these two reasons why exactly your data has NA values. These are the reasons. And this is the reason why you have to impute your data set, all the variables. Yes, friends, that's about your missing value treatment. Next comes your, so how do you, what are the types? How do you deal with these missing values, right? So these are the different, there are n number of methods how you treat. These are the major ones. What you can do is you can delete them. Delete them in nothing but over here you have got here, this is the row, and this is the row where you, yes, you can do that as well. It is free. Here and here you're having missing value. So what you can do is you can delete the entire record in this way. This is one of them. But what if you have lot of data which has got NA values, will you not be losing the data? Yes, friends, obviously you'll be losing the data if you delete them, delete the records. The next is you can use mean imputation, mode imputation, and median. So mean and median can be used for, these are the very naive techniques, basic techniques that you can employ to impute the data, treat the missing values for your numerical or quantitative data. Then comes your mode. Mode can be used, it's also again a naive method for imputing the data, that is using your for mode for categorical data, right? So these are the naive methods. The advanced methods are prediction model. You can run your linear regression for each and every, you can run your linear regression model on top of each and every variable. For example, we have got multiple variables. First time, if you have got NA values for x1, so this x1 becomes your output variable, and rest of the variables will become your input variables. So what you do is you impute those NA values, you predict those NA values using these input variables. Yeah, this will take time. For large data sets, it's definitely going to take time. These are the different methods. We also have your KNN imputation, K nearest neighbor imputation. So you can use that method as well for imputing the data. And there are many more. There are also, there are packages as well. You have got packages to impute the data. You can do a research on that, and you can find out the packages to impute or treat your missing values, because this is very important to treat the missing values. So this is about your missing values, reason why exactly they occur, and why is it. It's not that any method is important. It again depends upon the data set, the size of the data set. Yes, absolutely, Narayan. If you are deleting the data, then it means that you are losing the information. Probably if you, that is the very basic method. If you're deleting the data, you'll definitely lose the pattern and the information. So age, what is age? Yes, friends, what is age? It's an integer, right? Or a numerical variable. Yeah, you can use any one of these methods. It's, there is no hard and fast rule to use this particular method for that, any type of variable. It's nothing as such. So it will take a long time, Rakesh, if you run a prediction model. If you try to run a prediction model and if you try to impute them in R, it's going to take time. As of now, I don't have a small data set. What I'm doing is I have a very large data set on which will be implementing these techniques in R. And there was a question which method we have to follow. Initially, what you can do is you can use this mean, median, and mode for imputation for the beginning. And once you have got hands-on using these techniques, you can employ these techniques one by one on starting from small data sets, because it will not compute a lot of time. Understand how is it employing the model, employing the prediction, and then you employ the same thing on your large data sets. Because predicting the imputation or the missing values is not the scope of this webinar. It is part of this webinar, but if we try to understand that, it will take at least 1 hour. Then comes your outlier treatment. So we know for a fact that we have outliers. We get prediction model is nothing but, see over here, you have got the data set in this format, right? You have data sets in such a fashion. You have multiple input variables, right, and output variable. So what you do is you have x1 here, x2 here, x3 here, x4, and x5. So you have got 5 variables. So every one of them has got NA values. NA, NA, at some other place you have got NA values. So you have to impute all these NA values, right? So for the prediction model, for the prediction models, what you can do is, first time when you employ the prediction model, you'll have to treat this as your output variable. This will be treated as your output variable because you have to impute the NS for these values. You have to predict these values. Using these values, you'll be running a prediction model, and those predicted values will be replaced over here after you get the prediction model. You just do not have to run the prediction model. The prediction model has to be accurate as well, because you're going to replace those values over here. In that way, every time, each and every variable which has got the NA values will become the output variable, and rest of the variables will become the input variable. Got it? So this is the way how the prediction model works. You're welcome. And then comes your outliers. You have got, we know for a fact that most of the data, most of the variables have got outliers. So we know that we can identify outliers using box plot, histogram, and scatter plot. The box plot will be something similar to this if it is normally distributed, and over here, this is you'll have the outliers in this format, right? In the histogram, these extreme values, they can be said as your outliers. And in the scatter plot, you'll have the scatter plot in this fashion. These values can be called as your outliers. These are the different plots using which you can identify the outliers, but then box plot is the best one, which will give you the outliers. Then you can also go for your histogram and the scatter plot. Now, how do you have to deal with these outliers, right? First of all, we have dealt with the NA values, the missing values. Now you have to deal with outliers. Because of these outliers, your data may not be normally distributed, right? What you can do is, you need to first of all check with your subject matter expert. Check with your subject matter expert what is the reason behind the outliers for variable 1. I'm getting outliers over here. Is it a data entry issue, or is it a data capturing issue? For example, using some tool XYZ mechanical tool, you are capturing the data. If that tool has gone faulty, yes friends, there is a chance that you will be getting incorrect values, right? That could be the reason. So there could be different reasons. So you need to check with your subject matter expert for identifying these outliers, the reasons behind outliers. Now, if you have got the information, it's well and good. Or if your subject matter expert says yes, but then if it's a very small data set, then you can look at the data set and you can say that yes, these are the outliers. What if you have the data in lakhs or thousands? Is it possible for us to look at the data and identify the outliers? Yes, friends. No, right? That is the reason why we have got these plots and functions. For small data sets, we can look at the data and we can say that yes, these are the outliers. But for normally we do not deal with the small data sets, right? In real time, we'll be dealing with large data sets. Now, what you can do is to remove the outliers, you can probably delete the observations. It's exactly similar to your imputation method, deleting the observations in imputation. So if you delete, you will be losing the data, right? Losing the data is nothing but losing the patterns. You can transform the data. For example, there's a variable called as x1, right? It has got outliers. So probably what you can do is, we'll discuss this transformation in a while. You can try out root x1 and check and do a box plot and see if you're getting the outliers or not. If not, then consider x1 square root of x1 instead of x1. In that way, try out different transformations, right? All the transformations, please try them and employ and check if you are getting any outliers. If you're not getting any outliers on any of the transformations, then you can use that instead of the actual variable. Then comes your imputing. You can also perform the same imputation that we have discussed just now. Here we have discussed the imputation method, right? Yes, we can know which variable has got the outliers. There are functions. We can identify which variable. We'll look at once we implement that in R. We can identify which variable has got the outliers and what are the numbers, I mean the observations which has got the outliers as well. So in order to treat the outliers, you can employ these missing value techniques as well. You can employ these missing value techniques and you can replace the outliers as well. Imputation can also be used for treating your outliers. Now you can also treat them separately. What do you mean by treating them separately? Treating them separately is nothing but, for example, you have got a data set with outliers at different places. And there will be few observations which do not at all have the outliers. Yes? Say the first few observations has got outliers, and just for the sake of understanding and discussion, from here on to here, or rather, this is non-outlier data set D1, and this has got outliers D2. What you have to do is you have to separate the data into two data sets, D1 and D2. Consider them as different data sets, and you have to do two projects, right? You have to perform your EDA and all the prediction modeling or the classification modeling on this particular data set. Similarly, you have to do that on this data set so that whenever you run your algorithm, these patterns which are read from D2 should not be implemented or imposed on D1. That is the reason why what we do is we separate the data sets. We run the model on this data set. Again, we run the model on this data set. All that EDA should have to be done on both the data sets. Yes. Then you combine the results of these two data sets and hand it over to the client. This is about how you treat your outliers. Next comes your transformations. Yes, friends, why exactly is the reason for transformation of the data? Sure. Treating them separately is nothing but you'll have outliers. Yeah, even for the classification, you can do that. Just not for prediction, you can do it for the classification as well. See, you have got the data set in this format. You have got different variables. Yes, friends, X4 and so on. So your data set will have, say, assume these few observations do not have outliers at all, or what you can do is you can separate your variables as well. From here, just a moment, let me rewrite it. In this way, you have got the data set. You have the data set in this format. So what you do is, whichever is the outlier, I mean to say whichever observation of the row number, that will be separated. Meaning, for example, from here on to here, it was a non-outlier. All the observations were non-outliers. From your R, you got to know that these were non-outliers and these observations were outliers. So what you do, you separate these two data sets into two, this and this, D1 and D2. You have to implement your objective, the problem statement on both of them. Finally, you will be getting result 1 and result 2, whatever is the classification or your prediction model. Then you combine your result as R1 plus R2. Is it clear? I mean, R plus in the sense you're just combining the results, you're not adding the results. Then comes your transformation of your variables. So friends who have already completed the data science course or who are going through the data science course, do you remember what exactly is the reason behind transformation of your variables? Absolutely, absolutely, Tejaswini. Because reason being to make the distribution normal. Yes, Vijay. It is because most of your statistical techniques work very well on the normally distributed data. So only if you have the data in this fashion, then your statistical techniques, absolutely, for the reliability and the accuracy of the model, this is very important, or at least close to your normal distribution. So because of which we strive for the variables to get the normal distribution. And what are the common methods of your variable transformation, friends? You can try out, if you have got any variable called as x, you can try out 1 by x. You can try out x square. You can try out 1 by x square. You can try out x cube, log of x, 1 by log of x. You know, you can try out exponential of x, 1 by exponential, and whatnot. Whatever comes to your mind is logical, is you can employ, and it is directly proportional to amount of time we have to complete the project. Yes, friends, amount of time which is given to you. For example, if you are given just 1 or 2 days, will you be able to perform all these transformations and try out? It's not possible, right? Because you have other things to do as well. So it's directly proportional to the amount of time you get in completing the project. Now you also have got Box-Cox transformation and your Johnson's transformation as well, apart from these. So after, once you practice a lot, once by just looking at the distribution of the data, for example, if it is a right skewed or if it is left skewed, just by looking at the distribution of the data, you can say that yes, this is the kind of transformation which is going to work on that distribution. That comes by practice. Yes, absolutely, you can do that. Once you practice a lot on it by transforming the variables, if they are right skewed or left skewed, you can get to know that which transformation works on right skewed, which transformation works on left skewed, which transformation works on this kind of a data. All those things can be predicted upfront only by looking at the transformation, but that comes from practicing a lot. Then comes your, finally you have got the variable creation. This variable creation and variable transformation put together are called as something called as feature engineering. So this is again your feature engineering is considered to be heart of EDA. Your EDA is the heart of the project and feature engineering is the heart of EDA. Now feature engineering comprises of variable transformations plus variable creation. We have discussed about variable transformations, and now you can see that new variables can be created in either of these two ways. For example, over here the dataset had employee underscore code, gender, date. So what it was done is, from this date, the date was separated, month was separated, and year was separated. This is kind of feature engineering. But this is a naive technique. What you have to do is, you have to use your domain knowledge. Say you have got 10 variables and you feel that there are 2 to 3 variables which were left over by the client, which should have been included, as part of this data set, so that they will, mean a lot, and you'll get a lot of information and significance from those variables, so that your project will be more accurate and reliable. So if you are sure that you can come up with those variables, for example, I had distance and time in my previous, when I showed the dataset, screenshot of the dataset. This, so what I did is I created a new variable called as speed, which is equal to distance divided by time. Is it not making sense? The speed at which it's going to deliver. So in that way, you will have to come up with new variables using the existing variables, right? Using the existing variables, you have to come up. Now, this is the first way. The second way is creating the dummy variables. Dummy variables is nothing but converting your categorical variables into, or the factor variables into, your numerical variables, that is your integer. It can take any, it can take either 0 or 1. Over here you have got male as, wherever you have, since it's taking only male and female, right? It's taking male and female. So what you do is, it can, in any observation, this value, the gender, can either take a male or a female. So what you do is, you assign 1 to any level. Let me assign 1 to male and 0 to female. So what I do is, I replace this male by 1 and female by 0 throughout the column, throughout all the rows for this column. Similarly, we have got variable of female over here. So in this particular row, we'll have only 1 1 and 1 0, right? Here you have 0, you have got 1. So in that way, you have, there are packages, functions like dummies. I will package and also dummies and model dot matrix will create the dummy variables. You can explore on them. In R, we have got these packages, model dot matrix and dummies is a package using which you can create the dummy variables. So that's about the steps which are involved in your exploratory data analysis. So what we'll do is, we'll quickly, let me just look at the questions that we have. If I did not happen to answer anyone, can we predict the type of transformations by looking at the data? This was addressed. Then standardizing to get the accurate prediction model. That was an answer to make the distribution model. Yeah, for even classification, Sujit had a question about classification. What exactly was that, Sujit? Can you please come again? You are connected. I don't think so. Sujit is connected. Fine, not a problem. Any questions you people have, you can post it now. I believe combining the results. Yes, even for the classification model, this applies for prediction and classification. It's not that you just have to. Yeah, even if you have got three variables, say, just a moment, what was the last? It's just average. No, it's not an average. So what we were, we were discussing about separating the outlier and the non-outlier data set, right? You employ the same techniques. You employ the same techniques on both of them, and so that the patterns are not, since the patterns are different, right? For the outlier and the non-outlier, they will not be imposed on each other. Even for the classification model, you can apply the same technique. So data more, how can we normalize the data? So that is about your Narayana, that is about the transformations of the data, right? We just have discussed the various transformations. You have to employ the transformations. Absolutely, Ramakrishna, you have to do the EDA for all the variables. It is not that you just have to do only for one variable. Exploratory data analysis has to be done on all the variables. On the entire data set, you have to perform your exploratory data analysis. Everything has to be done. That will be a naive technique, but you need to separate the data using R itself. You need to write a function and separate the data. Variable transformation is, normalization is, normalization is also a kind of transformation, because what happens is, if you have different data sets, for example, different variables which are taking different values. For example, you have got the first variable which is taking x1 in 0.1, and the maximum value is taking is 5.3, and the next variable is x2. Yes, we'll do that in R. So this is taking the values 50, 60, 70, and so on. So the range of these two variables is different. Yes, friends? The range of these two variables is different. So if you have any distance calculation method, if you're employing your unsupervised machine learning techniques such as your clustering, if you are employing clustering wherein your distance is present, distance calculation, over there you need to standardize the data, right? Either you employ your Z transformation or any other transformation technique to bring down all the variables on the same working scale, so that you have equal, the range will be the same for all the variables. That is standardization. And transformation is nothing but, say you have got the data which is taking this kind of distribution. If you plot right skewed or left skewed or something like this or something like this, in this fashion. So what you have to do is, you need to employ, instead of x, you can try with different, you can try 1 by x, 1 by x squared, 1 by x cube, log of x, 1 by log of x, box transformation, and Johnson's transform. There is no limit to it. You'll have a lot of transformations, and Johnson's transformations. You can try a lot of things. Check which technique is applying, which transformation is giving you a normal distribution. So we have questions from data in this. What are the conclusion we can get in third and fourth moment decisions? You tell me. Did you happen to complete this thing? What is third moment and the fourth moment business decision, friends? Third moment and fourth moment. Skewness and kurtosis, right? Skewness, what does skewness give us? The distribution of the data, the variance in the data, right? Is it normally distributed or not? Sorry, is it normally distributed or not? Right? If this is a normal distribution, but this is a right skewed. and this is a left skewed data, right? Left or right skewed? Do you have a lot of data points which are concentrating over here? Yeah, do you have the extreme values in this way? Are they taking different values? Because it will be on an axis. Yes, absolutely, Vinay. It has to be, normally distributed. You need to try, transforming the data and bring down the data to normal, approximately close to normal distribution. So that is the reason why we have to. And kurtosis, what does kurtosis tells us? Yes, even for categorical and integer variables. Yes, kurtosis gives us the peakness, right? So it gives us something like this. Just assume that the data is normally distributed and you're getting a kurtosis something similar to this for one variable, kurtosis something like this for another variable, right? Here, the variance is less, the spread is less, the dispersion is less. But over here, there is a lot of variety in the data. The values that the variable is taking are different. Here, the values that the variable is taking is within this range, mostly. But over here, there is spread in the data. Right? This is about perfectly, or you can expect close to normal distribution, approximately close to normal distribution. So Tejaswini had a question about separating it manually. If I understand that correctly, is it date in that example should be no, you have to write down a function date. For that you'll have to use R code to separate it. You don't have to do it manually. Okay, all right. So that's about your exploratory data analysis. These are the different techniques that you need to employ as part of your exploratory data analysis. If they are, it doesn't mean that they have to be less. They have to be more or less the same. They have to be close to each other. If the values are more or less the same, then it means that your median and the median is the same. It is normally distributed. Advantages of variable creation is that it will give you more data and more patterns for the model. And just for the sake of creation, we don't have to create the variables, but that has to also get importance to your data set. It has to get the valuable information. Otherwise, it will not make any sense. Using the domain knowledge, you have to come up with new variables if you can, or else not a problem. But it's better if you IQR is concentration of the data, 50% concentration of the data. Yes, friends, in your box plot, you have got this is IQR. This is the 50% concentration of the data. The values where from here on to here, these are the values where the 50% of the the variable is taking, right? That is your IQR. Okay, this is 25, this is 100. So between these range, the 50% of the data is lying. These kind of questions will be asked by the client. So we just have to be ready with all these questions, answers for these questions. What transformation if data is parallel to x-axis? So you need to try, Palak. You need to try out different transformations. You need to research and you have to get that. Probably, you need to tweak. You need to, for example, if it is something x, you can try x plus x square or 1 by x plus x square. In that way, you have to try out different things. This is a webinar, Madhusudan. This is a webinar. So, we will be continuing with the course. Whatever course is being going on, that will be continued. And this is the webinar on the a new topic or any important topic that has to be discussed. Occasionally, every now and then we'll be taking webinars to stay connected and to share the information. And you also have bivariate analysis as well, apart from this, univariate, wherein you, for example, you have got scatter plot. Will be checking the relationship between two continuous variables, x1 and x2. Say you have got two input variables. Is there any pattern which is going on between two input variables, right? So there are different techniques to also check for your bivariate analysis. So let's quickly perform these steps in your exploratory in R and check. Give me a moment, please. Yeah. So I have a data set. Let me show you. This is the data set. Is it opened? Yeah. So the data set was in this format, friends. The data set that you're looking at, it was in this format. You have got year, you have got month, day of week, actual shipment time, planned delivery time. You have got the carrier names, number, planned time of travel, shipment delay, source, destination, the the places, distance in miles, delivery status, which we have to identify, which we have to predict. So this was for only for 2008 data. Is it? Okay, just a moment. Maybe. Can you see the screen now? Yes, friends. All right. So this is the data set. Will be employing your exploratory data analysis. So first variable is your year. Then you have got month, day of week, actual shipment time, planned delivery time, your carrier name, its number, carrier number, planned time of travel, shipment delay in minutes, source, the place, destination is again the place. You have got the distance and distance in miles. Is it that everyone is not able to see the screen? Delivery status. Yes, friends, please confirm. Okay, so maybe some problem from your end. Fine. So this is the data set. So what I did is I initially cleanse the data and have replaced the values. So we'll be performing on the cleansed data. So the year was removed from that. So here is our data set. So what I'm doing is since this data set has got around, once I load the data, I'll show you the dimensions, the size of the data. So what I'm doing is I'm using this function or the package rather data.table, which is extremely useful for very large data sets that you are handling in R. Normally, if you try to use read.csv or read.xls, then it will your R may crash or it will freeze for a long time because the size of the data set is very huge. So this data.table function, the package from this data.table will help you a lot. So I'll invoke that and I'll be using fread function to read the data. So my data set is cleansed data on which I'm performing exploration. See how much time is it taking. You can see over here there are 35 lakh 22,573 rows. So that has been read in just 6 seconds, 0.136 GB of the data. Yes, friends, it just took 6 seconds to read that amount of data. So let me do a view of the data. Let us look at the data. If I view of clean, sorry about that, clean underscore data, you can see that this is the cleansed data that we have. We have got month. I have changed the values to 1 till 12, day of month 1 to 31. Similarly, day of week, carrier name, delivery status, and these have been discretized to regions, shipment delay in times, planned time of travel, and so on. Right? And this delivery status, I think, got your output variable of interest. So let us perform your EDA. So the class, why I'm changing the class of the various data set is, if you look at the class of your data set after you have loaded the data, it will be data frame. Initially, it will be data frame. It will take some time to perform actions on a data frame. So what we do is from the data.table, we'll be using this set dt. If you want to set a data frame to data table, you have to use set dt. And if you have to change from from data table to data frame, you can use set df. Set dt and set df to change the data types. So I'm convert the clean underscore data to data.table. Now you can see that the class of your clean underscore data is now changed from data frame to data.table. Now another thing what you can do is you may have redundant data in your data set. You may have similar rows, exactly similar rows in your data. So I'm trying to first, what I'll do is I'll try to find out the dimensions of the data. You have got 10 observations, 10 features, columns, and 35,22,573 rows observations in your data set. Now, data frame, there's nothing difference. I mean, both can take different data types, but then the processing is different. Data table, if you convert it to data.table, it will process fastly. If you perform operations on data.frame, it will take some time. That is only. Yes, source and destination were there, they were required, so we have used them. Next, we'll move on to the finding out the unique data. That is nothing but we'll try to eliminate the redundant rows that we have. So if you run, so that is again, you have to write down a function, Tejaswini. What you have to do is you need to write down the functions, and you have to, perform those functions on that column, and you have to change the values. So for you can't do that manually for thousands and lakhs of data. What you have to do is you need to write down the code and change. Probably you can do a Google search and find out how do we have to discretize using R. Then you'll get the code, implement the code in R, and discretize the values. We are just replacing the value. For example, if there is some value which is from 1 to 10, it has to take region 1. If it is 11 to 20, it has to take region 2. In that way, we have to write down the code. Yeah. Data type, I have not yet changed. We'll be looking at the structure in a while. Once we look at the uniqueness of the data, if there are any duplicated rows. So you can see that if I run the dimensions of the unique of clean data, I have got 33,779,000 rows which are unique. So there is redundant data over here. So what I was doing is using this line of code, I'm trying to eliminate the redundant data, or rather I'll be finding out the redundant data here. I mean the unique data here. So this is the unique data, and these are the observations which are being duplicated. So what I'll do is I'll get rid of them. I'll say that clean of data should be equal to unique of data. So this is your unique data. I'm assigning that to the object clean data. Done. So now you can look at the dimensions of your n number of rows. It's your 33,79,000 rows we have, which are completely unique. Now these names of clean data will give you the column names, right? And what I'm doing over here is I'm moving this delivery status to the last position using this line of code. So over here you have this clean data. I'm moving this delivery status to the last position and rearranging the columns. So in that way, if you look now the names, you can see that initially the delivery status was here. Now the delivery status position has been moved to the last position. Fine. Now we look at the structure of the data to identify the data types. Over here, you can see that month is taking the value integer Day of month is taking integer because it's assigned a number. Day of week is taking again a number, integer. Carrier name is character variable. Distance is integer. Destination is character. Source is character. Shipment is integer, since it is taking the numerical values, numbers, not decimals. Plan time of travel, delivery status. So this is the structure using which structure command using identify the variables, right? What are the data types that R is considering them. Now we know for a fact that your month, day of week are factor variables. Yes, friends. 1, 2, 3, 4 are factor. They can take only limited values. So I have converted them to limited values, factor. Then 6, comma 7. This cannot be a factor, integer. It can take any value, distance, right? Then your region and your source and destination are again factors. And again, your 10th variable, delivery status, is your factor variable. So I'm converting all those to factor so that they take only, see, you can see over here, they have been converted to factor, right? So in that way, you need to identify, put your common sense and domain knowledge to identify the variable types. Now let us look at the summary of the data. So if you look at the summary of the data, you'll get some understanding about the data. So your month over here, or rather what we'll do is, it's not computing the mode. So it has got 6 ones. You can see over here, friends. It's taking 6 values. Or let's try to understand the numerical data. You have got the distance over here. So the minimum distance is 11 miles and the maximum distance is 4962. So the range will be 4962 minus 11. You can directly get the range as 4951. Then the median is also provided. The mean is also provided over here. It's bit, you cannot be, by looking at this range 11 to 4962, you can say that mean and medium are not that too far, because you have got a wide range over here. Similarly, you have planned time of travel, which is starting from -31 to 1439. So you have got the mean and the median, which are also approximately the same. So by looking at the numbers upfront, we can say that is it going to follow normal distribution or is it not going to follow normal distribution. Yes, and you can also have the values of your mean and median. Then you have the first quartile, the third quartile values as well. So between your first quartile and third quartile, you will have the 50% of the data here. So in that way, you have to, and you can also see that when these are the number of observations for your 0, and these are the number of observations for your 1 in delivery status. So in that way, you have got the summary. Now let us perform your mean, median, mode, range, and all those things on the integer variables. So over here, we'll choose one variable, that is your distance. We'll be choosing distance over here, this column, and we'll perform the numerical descriptive analytics on top of that. You use mean of the variable, you get this 743, you get the median. Then you find out the range. Then you'll find out the variance, the third moment and the fourth moment, the second measures of central tendency followed by measures of dispersion, the variance and the standard deviation and the range. These are the values. You have to interpret these values. What is the variance? Is it more or is it less? Then comes your histogram. What is the distribution of the data? I'm running the histogram on top of this variable. So what kind of a distribution is it taking, friends? This distance, what kind of a distribution it is taking? Is it close to normal distribution, or is it left skewed, or is it right skewed? It is right skewed, right? So we have to strive, we have to employ techniques on top of this variable to get that distribution close to normal, right? So what I'm doing is, so before I do that, let me plot a box plot. So what I'm doing is, from here on to here, I'm plotting a box plot, or rather what I'll do is over here, box plot of this. I'll run this command here. Now, since it is a big data, it will take a while to get you the box plot. It's taking some time, friends. See, this is the box plot, and you have got lot of outliers in the box plot, right? Yes, friends, got it? So it means that there are a lot of outliers in the data set, and those outliers can also be the real data as well. We cannot claim that those are the extreme values, that those are not the real data. At times your outliers can also be the real data, because of which it is better not to delete the outliers and treat them separately. But first we need to check with the subject matter expert as the reason behind the outliers. So in order to find out the outliers, what you can do is you can run this command, box plot of distance. I'm putting plot as false so that it don't take time, and I'm giving a $sign of outliers. It is giving me all those row numbers where it is taking the, these are the values, I'm sorry, these are the values of your outliers. You can see that the values are being repeated a lot. So these are the values of your outliers. It only takes 1000 values, and it's not going to display you all the values. So by doing the length command on top of that, you get to see that there are 70,000, or I'm sorry, 1,77,000 outliers. Is that possible to have 1,77,000 outliers? Because we have got a very large data set. So we have to be very careful while deleting and treating the outliers. And when we have to also check with the subject matter expert, try out all those things that we have discussed. So we'll try to print the unique outliers. What are the unique values? I mean, they are getting repeated, right? So how many? So these are the 100 and 177, 172, 173, 74, 176 values, right? These are the 176 outliers that you have. The values, they are getting repeated. Quantile function using the QQ plot, are you saying, Harish? You can also run the Q norm. You can also run, but maybe you'll not get these values over there, right? You'll not be getting, if you run Q norm of or QQ line of your clean underscore data dollar distance, you'll get the plot. Since it is a large data set, it takes time. And if you're not converted that to data.frame, data.table, it will take even more time. So you have 182 unique outliers, unique out values that are occurring over here. These are those 100 unique values. So you need to check with the subject matter expert, what is the reason behind these values? Is it a data entry issue, or is it, what exactly is the reason? Are they actual values or not? So these values are creating the problem in that variable. So in that way, these are the outliers. So what you can do is, what I did is, over here I have stored the outliers in a different object altogether. I am storing these outlier rows in a different object for variable distance. So I'm saving that in distance underscore out. So if I run this command, and if I get to see the number of outliers, you get 177,683. This is the exact number that we have got. Right here you have got 176683 as outlier, number of outliers that you have. So you can look at the data set. I think the class of this is a data frame, if I'm not wrong. Yes, it is a data frame. Sorry. Yes, data.table. If you look, view of dist underscore out. So these are the values of your variable. See distance. All these values are outliers. 2237. So all these values are your outliers. A lot of values are there. So I'm separating the data. Finally, I'll combine the results. I'll do R bind. So that's about your distance, right? So you have performed what all did we do? We perform mean, first moment business decision. We can also do skewness and kurtosis. Right? For that, we need to install a package called as library of moments. Moments is the package which you can use to find out the skewness and kurtosis, because you do not get the skewness and kurtosis directly along with the base package. We'll have to use skewness function, and on top of this clean underscore data on this variable distance, I'll find out the, so it happened to be 1.60. So by looking at this value itself, you need to say that upfront, is it a right skewed or a left skewed? If it is a right or a left, I mean, is the tail long, or is it moderately right skewed, or is it very slightly right skewed? So there are thumb rules for your skewness as well. So you can explore on that. What is the range for your moderate skewness? What is the range for your extreme skewness? And what is the range for your zero skewness? And you can also use the kurtosis function, kurtosis of your clean underscore data dollar distance. You can see the value is 6.19. So again, there is a range for kurtosis as well. So these values, by just looking at these values, you should be in a position to say that yes, it is a right skewed, left skewed, it has got a high peak or a low peak. Is there a lot of dispersion in the data, or do we do not have any dispersion in the data? That is what you have to interpret. It will not give you any plot. It is just a number. So we'll be running the histogram. We'll be running the histogram on this distance variable. You can see that from the histogram it is right skewed. The peakness, as I said, what you can do is you can explore on that, Tejaswini. You can explore, because this is slightly tricky and it's interesting to explore. You explore on the range which says what is the range for right skewed. Here you have got minus 1.6, right? So it is positive. It means that it is positive. It's not zero or negative. It's for sure that it is right skewed. But is it extremely right skewed, or is it something like this? I'm sorry, what? It is something like this. Yes. So that you have to identify by knowing the range. What are the brackets for extremely right skewed, moderately right skewed, and zero skewed? We have got the values for extremely left as well. So right or left, it will be the one bracket. So you'll have one bracket, you'll have one bracket, I've got one bracket that way. Similarly, you have for, this is for skewness, this is for kurtosis also, you have some bracket. If your value is falling within this bracket, you can say that yes, it is extremely right skewed or extremely peak. Or yes, if it is falling within this range, you can say that it is moderately peaked. You have got moderate peakness. If it is something like this, then you say that there is lot of variation in the data. This way, the peak is very less. So just by looking at the numbers, we need to identify. Your statistical techniques do not work very well on the skewed data distribution, right? We have discussed that. Our objective will be to bring down the data to normal distribution. Yes, because the statistical techniques work very well on the normally distributed data. Next, We have found the outliers and we have separated the data set. So let me employ, we'll perform the exploratory data analysis on, since we are not done. It's not, we cannot say that it is normal, Narayana. It can be something like this. It can be something like this. Is it not having a high peak? Even though you have a high peak, you are right skewed. It is right skewed, right? From here on to here, the dispersion, the variance in the data is very less if you exclude these values. Yes, these could be outliers. Again, we need to identify. So after you find out the reason behind outliers, after you work on the outliers, again you can plot and see whether the distribution is normal or not. If it's eliminating those, the right skewedness or not. Next, what you can do is, what I'm doing is, since it is right skewed, right? So I need to work on that variable. I need to work on the variable and try to perform different types of techniques to bring it down to normal distribution. So what I did is, I have tried different transformations, and it was found that square root of 1 by 4 worked very well for me. So what I did is, instead of just considering planned time of, or this is for planned time of travel, right? So we were working on distance. So yes, distance also gave me the fourth root of distance gave me a normal distribution. So what I did is, I have plotted a histogram. Let me take you to the feature engineering code. And over here, before I take you to the feature engineering code, this is the function to compute mode of any categorical variable. Well, once we get to the categorical variable, I'll describe that. We'll discuss on that. So where is that? All this while we were discussing about the skewness and kurtosis, right? So you need to explore on this bracket the thumb rules which are present for the, for 1.6. What is it going to be? Is it going to be a right skewed or a left skewed? Yes, Prashant? Is it positive value or a negative value? Is it close to zero, very close to zero, or is it away from zero? Since it is plus 1 point, it is positive, right? So it definitely, it will be a positive skewed. But again, apart from just being positive, is it going to be a hugely positively skewed or a marginal positive skewness you'll have? That you have to identify by looking at the number, right? So that there are some brackets. I would want you to explore on that, identify those ranges using which you get to find and say that yes, it is a moderately skewed, moderately right skewed, or moderately left skewed. Fine friends, we are running out of time, so we'll move on to the feature engineering part of the distance variable. See over here, what I did is, I have converted the variables. Over here we had the day of week was in numbers, right? So what I did is, I converted that to a week 1, week 2, week 3, and so on. I'm creating a new variable altogether using these days of week. This is days of week, right? Monday, the first day, second day, and so on. So using that, I'm creating a new variable week, which is going to take different values: week 1, week 2, week 3, week 4, week 5. So at the max we can have 5 weeks in a month, right? Based on these conditions, if the day is less than or equal to 7, it has to be coming under week 1. If the day happens to be less than or equal to 14, greater than 7, and less than or equal to 14, it has to be week 2. In that way, I have created this new variable for call as your week. And again, I have created another variable which is speed of travel, that is your distance divided by planned time of travel, which is going to give me speed of travel in miles per minutes, or yeah, miles per minutes, because planned time of travel is in minutes. I'm working on distance variable. Now your distance was not normal. So what I did is I have tried out different transformations, and it was found that fourth route is giving me the best results. So what I did is I transformed it and plotted. So did it not convert to your normal distribution, friends? From right skewed, it got converted to a normal distribution. Yes. So in that way, we need to try out all the possibilities, friends. We need to try out all the possibilities, and we have to check which one is giving the you know the data distribution close to normal. Maybe it should not be exactly normal, but even if it almost approximately normal, that is fine. Next comes your, so I have plotted, I have looked at the, after I transform the variable, I need to look at the outliers once again. So let me look at the outliers. How many outliers do I have? I have got, earlier I have got 17,000 or so. Now it got reduced to 5,051. Yes, we have discussed that in our outliers. How do you have to treat the outliers? You can try out, where is it? You can try out the transformations as well. Transforming the data, that worked for us, reducing the outliers. Now let me look at the unique outliers that I have in this 5,051. The unique outliers is just 19. So there are 19 values which are acting as outliers in the entire data set for that. I mean to say for that variable distance, for all those rows, the unique rows that we have. So what I'm doing is I'm converting this distance to the power of 1 by 4, and I'm renaming it as distance to the power of 1 by 4. So let me do that. So my variable now, instead of distance, it has become fourth root of distance. That I need to remember. I need to remember that it is not now just a distance, it will be fourth root of distance. Similarly, you have to perform for your categorical data as well. Let me take a categorical variable. Where do I have that? Yes, it's done on the entire variable, on the entire rows. You're performing the transformations. Are you selecting any specific rows and you're performing those transformations? You're performing the transformation on the entire column, right? All the rows. Now they have been earlier I did that. I just showed that how you have to separate them, right? But even after you do this, say 19 are the rows which we cannot, which we cannot work on anymore, which cannot be reduced further. Those are the ones that we have to deal with. Now you can separate those outliers. 19 rows you can separate now. Since the code was written there, I just have executed and showed you how we separate the outliers. Got it? Now you can separate these 19 outliers. You need to first, what you have to do is you do not separate them immediately. You try out the descriptive analytics on all the variables and then finally separate the outliers. So what I'm doing is now I'll be working on a categorical variable. Yes, absolutely, Narayana. We have to, strive to get the normal distribution on all the variables. So let me see. So month, we have got month over here. So before I work on a categorical variable, let me run the mode function, because you cannot compute mean, median, variance, standard deviation, or all those things on your categorical variable, right? That you can perform only on the numerical variables. So you need to write a code for mode. This is a function for mode. Since you do not have the function mode in R, so here I am trying on this particular variable, that is your month, day of month. Now I get to see that these are the values that it is a factor variable. It is from 1, 2, 3, 4, 5, 6. So month is taking only 6 values. Out of those 6 values, 3 is occurring more number of times. Now how do I visualize that? I visualize that using a bar plot. But before that, let me also show you the proportion table, right? So this is the command. Table of any variable will give you the values, how many number of times it's being used. You see, 5,64,000 times one was used. One occurred 5,64,000. Then two 5,27,000. In that way, you have got the results for all. Now, if you want, you cannot represent it this way in real time. You have to always represent in proportion. So proportion prop dot table on top of that function is going to give you the in percentage format. So there's some error. Let me see. Yeah, over here. Till here we need to run. So you're getting 60.166. So I'm rounding it off and sorting this. I'm saving that in mon underscore prop. Mon underscore prop is this one. So 17.08, that is your third month is occurring more number of times. So if you view that particular object, you get the proportion table in this fashion. The frequency of the month is 17.08 times, which is the highest. So if your client asks you which is the month which is occurring more number of times, this is the month. Now you have to represent the same thing in your bar plot, the visualization. So I'm representing that using a bar plot, and I'm using the object as mon underscore proportion. I'm using this one to represent the bar plot because it's taking the frequency as well. You cannot use just a variable. You also have to use the frequency. So this is the plot that you have got, and I'm labeling that plot in this fashion. So this is the bar plot that you have got in R. Third one is taking 17.08%, right? Is this clear, friends? How we are representing the categorical data, the frequency of the categorical variable in this fashion? Yes. Now, standardizing the data variables by using Z table versus transformation each variable. See, Z transformation, you can try out Z transformation as well. Z transformation, what it gives you, it brings down the variable on a working scale. Like, for example, over here, where is it? Here, for example, if you are performing clustering, unsupervised machine learning, wherein the distance measure is computed on the data set. What are we doing over here? Are we not classifying between 1 and 0, the delivery status? Yes. Are we performing any clustering over here? Maybe you can perform clustering as well, but as of now, the objective is to classify the rows appropriately with good accuracy between the delivery status 1 and 0. Is it going to be delivered on time, that is 1, or is it not going to be delivered on time? That is our objective. So for example, if you are using any supervised machine learning technique like decision tree or KNN, that is going to classify it, right? Over there, if there is no distance measure which is employed by the algorithm, you don't have to transform the variable. Only if there is any distance measure which is being used by the algorithm, like your hierarchical clustering, then or KNN, in clustering you employ the transformations, Z transformations. So the mode happened to be 18, the mode of month. So we were working on month. Now this is for day of month. Earlier we worked on month, right? Then the day of month. So in that way we perform this thing EDA on the categorical data as well. So finally what I did is feature engineering was done. I created one variable over here and another variable, and I rearranged them. And what we can do is, using this line of code, where is it, separating the data here. In that way, using this command, using separate the rows, you can separate the outlier data and non-outlier data. So this is going to give you one variable, one data, right? Distance dot out. So if I do view of distance underscore out, you are getting one data set of 1,77,000. Similarly, you have to come up with all the variables. You have to come up data sets, and you have to do r bind of all, like distance underscore out, shipment time. So let me just say shipment underscore time was one variable. In that fashion, you will be combining all those rows. So is it not that you may have duplicate rows? Like distance underscore out may have the rows that shipment underscore delay is also taking. Yes, friends, are you getting the logic? You may come up with duplicated rows in outliers as well. So you have to find out the unique rows from this data set as well, so that you do not have the redundant data. So you model the outlier data set separately, and you model the non-outlier data set separately. So that's about your exploratory data analysis, friends. So we have discussed about your exploratory data analysis topics and implementation in R. So if you have any questions, please ask them. See, over here, R-bind is nothing but this is the first data frame that you're coming up with for your distance, right? The distance variable that we have worked. In that way, you'll be working on shipment delay. You'll be working on planned time of travel. You'll be working on different columns, right? Different rows. Everyone will have outliers. Every column will have outliers. Even after transformation, say 15, 20 columns, 15, 20 rows will have outliers. So when you combine all of them, that will have to check with the concerned person, Rakesh. That will have to check with the concerned person. And over here, coming back to the discussion, R-bind. So we are combining all those data sets. We are combining all the data sets, and what we are doing it, we are coming up with a big data set for non-outlier. That is something like this, right? This is something. Sorry about that. I did not draw it properly. So you'll be getting a non-outlier data set. Something similar to this. This may have repeated rows, right? The rows may be repeated, redundant data. Shipment will be considering the same row. Distance will also consider the same row if it has got the outlier. So from this one, you need to identify unique rows so that you don't have the redundant data. Probably you have only these many rows which were unique. So consider these rows and perform modeling on the outliers data. You come up with one model over here on the non-outlier data, one model on the outlier data. You combine the results finally, the output values. Clear? So that's about your exploratory data analysis, friends. We are done with the topic. Fine. Any further questions? For each variable, if we have the non-outlier and the outlier dataset, then how can we combine all the variables and all the datasets? This command over here, Tejaswini, it's including all the rows. it is including all the columns. It is including all the columns, and it is including the row distance which has got the outliers. So from here, what it does is out of 33 lakhs 79,000 observations, it will consider the outliers only for distance. Then it will consider the rows which has got the outliers. So this was the rows, right? So these were the rows. So these are the rows. So it has separated that data for distance. In that way, you'll have to separate each and every column, and you have to come up with you'll be coming up with a obviously big data set that has got redundant data. From that data, you need to find out unique rows. Find out unique rows so that you do not get the repeated duplicated rows. Then you work on a non-outlier outlier data set. Got it? So Palak, again we need to check with the the concerned person, probably with Ganesh. Again do your R bind. What you can do is you can give the results in a separate fashion as well. You can give the results in a separate fashion. Yeah, because you have got a lot of, the data set is very huge over here, right? So you can work on these many lakhs of rows in R as well. We just have to explore all the functions and the packages. Any further questions, friends? And there was a question on which model is good for the which type of data. It again depends on your research, Shravan. But again, you need to identify is it a prediction model or is it a classification model? What is the size of the data? Which algorithm is responding very well? Because not all algorithms will respond equally for each type of data. You may get a good response from one particular algorithm on a dataset X and a good response from another algorithm on a dataset Y. It again depends upon the type of data that we have. So we have to try out all the different algorithms. This is just an exploratory data analysis. From this exploratory data analysis, what you can do is you can draw a sample. You can, from that non-outlier and the outlier datasets, you can draw a sample. You try all the classification algorithms that you have learned on this by fine-tuning the parameters. Check for the accuracy. Accuracy 1 for one model, accuracy 2 for another model, accuracy 3 for another model, and so on. Also check the reliability. Then finalize the model which is giving you a good accuracy. Implement that on the entire dataset. Same is the case with non-outliers as well. Sure, Muthu. You can use decision tree as well. But again, how many, you have got the output variable which is taking two values, 0 and 1. Yes, subsetting of the data, random sampling, right? Do a random sampling over there. So there was a question about, so decision tree. You can employ decision tree, Tejaswini, but we can also employ logistic regression over here. Yes, logistic regression is used when you have binary output. Yes, you can employ. So you're using regression, and you can also use classification as well, right? In that way, we'll have to try out different algorithms, provided that our exploratory data analysis is in place. So since it takes a lot of time to work on this data, you need to spend at least 60% of your time on EDA. Once you are confident about your EDA, proceed with selecting the models by sampling the data and finding out the accuracies by fine-tuning the parameters of each and every model, and then select a model. Yes, Narayan. This data is not built. You have the data sets in R that comes along with the base package. So here, that is used when you have got excessive zeros in the data. Tejaswini, excessive zeros in the data set. So if you do data of this particular data, you run this command, you get, I'm sorry about that, it's already selecting passengers. You get to see these are the data sets. These are the names of your data set that you have in R. You can select any of the data set and you can start working on it. For example, if I do data of iris, iris is the name of the data set. It gets invoked in R by the name iris. So outlier separation on each variable will be done separately. Yeah, you have to do it separately. We cannot do it all. We may write a function, but that becomes complex, right? They become complex because box plot, is it giving you an outlier individually or is it giving you an outlier for all the variables at once? Yes, Anu. Box plot will be plotted for only one variable, right? But again, what you can do is we have functions that you can use. You can do a for loop, and in the plot over here, you can get the box plots of all the variables at once. You can look at the plot, provided that the data is small. It works very well if the data is not that huge, because it will be difficult to interpret. Like you have got only one bar plot over here, you can write down a function, complex function, and you can get different bar plots for all the categorical variables at once. You can explore on that. We have functions as well that people have already implemented. So anything else, friends, regarding your EDA? I haven't tried that. Let me see. Box plot of your data set. What was the name? Clean underscore data, right? Right. Did you happen to try? Because this is a huge data set. Maybe it takes time. Wait. Yeah. You need to scale it. So let me stop that. On you need to binary operator, right? So there are categorical variables as well. So I need to remove them and I have to probably try again. Yes, friends, any other questions you people have? Any doubts? Regarding the code and all those things, please, we need to check with the coordinator. Even I'm not sure. Just for the sake of understanding over there, I have not converted the week. I have created a week, created the variable over here. Tejaswini. Earlier, we just had day of a week. We created week 1, week 2, week 3, right? This as part of your variable creation, feature engineering. From this day of week, I came up with week 1, week 2, week 3, and so on, right? This 4 will be coming under, if this is 4, day of the week. I'm sorry, not from the day of the week. I have used day of month. Using day of month, I have come up with week 1. Using this over here, if it is 10th, it should be in week 2, right? So it will be week 2 for that. If it is 21, then it has to be 21, 20, it has to be in week 3. So in that way, I have created a new variable to check if it's going to work or not. Python, the logic can be the same. We cannot use the same code. In Python, the functions and the codes will differ, but the logic could be the same. The logic remains the same regardless of whatever tool you use. Yes, you can consider it, not a problem. You can say, you can have a column by the name week, and you get, instead of week 1 you can have week, excuse me, 1 2 3 4 5 5, right? You just have 5 weeks at the max, you don't have more than that. Again, what you have to do is, since they are numbers, it will consider it as integer. The reason me giving week 1 was, upfront it will consider it as character, then you can just do a factor of that, or maybe directly consider it as a factor. So what happens if you give numbers, it will consider, R will consider it as factor, an integer, and you need to again convert that to factor. So this was, week 1 was more appropriate for me, so I did that in that way. Anything else, friends? Fine, then we'll conclude the session. Yeah, that was your exploratory data analysis in R. So if there there's a question. So negative values is nothing but, I mean, that was, negative values is nothing but, it was submitted or delivered before the time. So I had to also work on that. So it's like, for example, if it was supposed, sorry, it was supposed to be delivered by 10 p.m. So it was delivered 15 minutes before 10 p.m. Something like that. Minus 15 is you're delivering before time itself. So all that cleansing and all those things should be done before EDA. There was a question, if there are 7 discrete values in a column, that impact magnitude by, suppose in simple linear regression, assign 1, 2, 3, 4, 5, 6, 7 discrete values in a column. Simple regression, you mean to say that, are you talking about simple linear regression? Yes, you can make them positive. Month and week, are they ordinal or nominal or categorical? Anup, can they be arranged in an order? First of all, they are categorical, right? First of all, they are categorical. On top of that, can they be arranged in an order? Yes, they can be arranged in an order. Hence, first they become nominal, and since they can be arranged in an order, they are ordinal data type. Got it? Yeah. So Palak had a question about linear regression. So linear regression, we had, you mean to say that there's a column, simple linear regression, there's an output and an input variable, right? This is X, this is Y. So this is taking different values, right? 1, 2, 3, and so on. 4, 5, 6. Right? Did I understood or interpreted your question correctly? So now what is that you wanted to ask? There are a lot of questions coming in. Let me go back to your question again. Just a moment, please. Yes, it will impact, right? For example, simple linear regression. But simple linear regression over here, you may, if they are not, say, discrete values. If you have got discrete values, what are you going to do? Yes, Palak. In simple linear regression, if you have got your X variable of interest as discrete, so are you not going to create dummy variables? Your, yes, absolutely. See, your Y has to be continuous. Y has to be continuous, but X can be discrete, right? Or continuous. There is no condition on X. this has to be continuous. So if you have X which is discrete, then you create dummy variables and work on it. Because what is the logic which is employed in your linear regression, simple linear regression? Ordinary least squares, right? Sure, Rakesh. Thanks for the suggestion. We'll try to get back. We'll try to conduct a webinar on that. So ordinary least square, is it not going to compute the distance? Yes. So you need to have the numerical values instead of the discrete values. Fine then, friends. We'll wrap up the session over here. And regarding any queries regarding the access to the recording and the data, code. Yes, you have to include the dummy variables. You're creating the dummy variables so that they have to be implemented and used, right? Yeah. All right, friends. Thank you all for attending the session. And regarding the access to the session recording, please check with the concerned person. Probably a message will be posted in the WhatsApp group, or else you may reach out to the concerned person. Yeah. Thank you all for attending the session. Yeah. Thank you and goodbye for now.